Hello everyone. So in this free lecture tutorial, we're going to discuss how we can combine some of the skills that we learned earlier this chapter and apply them to doing stoichiometry calculations for reactions that occur in aqueous solution. So I have an example problem here on the screen that we can look at and we can sort of navigate through to see how it is that we can use concepts of molar concentration to do these calculations that we need to do. So basically the situation in the problem is that I'm trying to find the concentration of a sulfuric acid solution. Okay. Basically I have 10 milliliters of it, and it's supposed to react with 15.9 milliliters of 0.15 molar potassium hydroxide. And they want me to calculate the molar concentration of the sulfuric acid. And so basically the first thing we need in any stoichiometry problem is a balanced chemical equation. And so I'm going to start off by representing the sulfuric acid, and that's going to react with potassium hydroxide. Again, this is a double displacement reaction, and so I should get potassium sulfate and water as my products. Now I'm going to balance the equation, so note that there are two potassiums on this side, so I'm going to put a 2 here. And basically, if I take a look, there are 1, 2, and 3, 4 hydrogens, so that means I'm going to need to put a 2 here to finish balancing the equation. Now, again, as I mentioned to you back when we covered stoichiometry in Chapter 9, the goal of any stoichiometry problem is to get to the mole ratio. In other words, whatever units that you may begin with, you're going to want to convert those to moles, then use the mole ratio to convert between species in the chemical reaction, and then finish off by then doing any conversions you might need to get to the proper units for your answer. And so here, we should probably begin with these 15.9 milliliters of potassium hydroxide solution. So I'm going to start there. So 15.9 milliliters. And I'm going to include a label, since again, halfway through, once we hit the mole ratio, we're going to convert to a different species. 15.9 milliliters of potassium hydroxide. Now, I'm going to anticipate using units of liters in my calculation, since again, I know that molarity is moles per liter. So the first thing I should do is convert from milliliters of potassium hydroxide to liters of potassium hydroxide. Now notice this sets me up for me to go and convert from liters of potassium hydroxide to moles of potassium hydroxide using the molar concentration that I was provided. And there were 0.150 moles of potassium hydroxide for every 1 liter of solution. Now, notice that if I cancel units, I'm in units of moles of potassium hydroxide. So that means that I can go ahead and use a mole ratio to take me from moles of potassium hydroxide to moles of sulfuric acid. So if we check the balanced chemical equation, we can see that that ratio is 2 moles of potassium hydroxide for every 1 mole of sulfuric acid. Now, notice that basically they're asking me for a molar concentration. I'm currently in moles of sulfuric acid. So that means I have to divide by the volume of the sulfuric acid solution. So if we notice, the problem did state that that was 10 milliliters. So I'm going to divide what I have so far by 10 milliliters of sulfuric acid. But notice that, again, molarity is again expressed in units of moles per liter. So if that's the case, I need to do one more conversion. I'm going to need to convert these milliliters of sulfuric acid to liters of sulfuric acid. So if I finish canceling out the units that'll cancel, you'll see that basically my units that my answer should be expressed in are moles of sulfuric acid per liter. So again, that's exactly what I want, since I'm trying to find a molar concentration of sulfuric acid. All that's left is for me to go ahead and do the math. So that's 15.9. I'm going to divide by 1,000. Okay, I'm going to multiply this by 0.15, and then I'm going to divide that by 2, and then divide by 10, and then multiply by 1,000. If I do this math properly, I should get 0.11925 moles per liter sulfuric acid. However, since I was given 3 significant figures in every piece of data in the problem, then I should round this to 3 significant figures as well. So that means I want to stop reporting the number here. And so since the number next door is a 2, that means the 9 stays, and I should report this as 0.119 molar sulfuric acid. Okay? So use this example sort of as a guide for you to construct your solutions for solution stoichiometry problems. And obviously, we'll work some of these problems in class. Feel free to respond to the follow-up question attached to this pre-lecture tutorial, and I will see you guys in class tomorrow.